Hi, everyone. Thanks so much for joining us for today's session, Data Mesh from Concept to Reality. During this session, we'll discuss how Bairesdev has implemented data mesh from the ground up with data solutions like Databricks and Monte Carlo. So to start, allow me to introduce you to our speakers today. First, please meet Mateus Espinal, Data Engineering Manager at Bairesdev. We also have Jason Pohl, Principal Solution Architect and Data Management Lead from Databricks. And my name is John So, Head Product Marketing at Monte Carlo. To just set the stage for today, let's also quickly introduce the company so you have the background and context for who we are. So Bairesdev, our feature story for today, is a software solutions company that provides leading businesses around the world with technology teams on demand. And you can see some of the folks that they work with there. And as many of you know, Databricks is the lakehouse company, a recognized leader in the data management systems, in data science and machine learning platforms, and the creator of Delta Lake, Apache Spark, and MLflow. And Monte Carlo, the creators of the data observability platform. And our goal is to help data engineering teams detect, resolve, and prevent data incidents before they impact the business. And you'll hear a little bit more about each of us throughout today. So for our agenda today, first, Mateus is going to walk us through the data mesh implementation of Bairesdev. From there, Jason's going to share how Databricks supports a data mesh architecture. And then similarly, I'll wrap up by sharing how Monte Carlo fits into and supports a data mesh architecture with a brief demo as well. And then we'll have Q&A at the end. So before we jump in, let's just quickly cover the 4 principles of data mesh that we'll refer to throughout today's session. The 4 principles that Zhamak Dagani has codified are first, domain ownership, data as a product, self-serve data infrastructure, and federated governance. First, data domains need to host and serve their domain data sets in an easily consumable way. For data as a product, the intent there is to apply product linking to data, including ensuring that data is easily discoverable, easily read, easily understood, while also applying product principles such as versioning, security, monitoring, logging, and alerting. Self-serve data infrastructure calls for tools and user-friendly interfaces to develop analytical data products for both analytical end users and development teams. And finally, federated governance are the overarching rules and regulations to govern operations through computational policies and services. So just keep these in mind as we go through today. It should be helpful as we refer to them. So with that said, with the basic understanding of 4 principles, let's jump right in. Mateus, over to you.
Hi, everyone. I'm pleased to be here sharing the reality of a data mesh implementation. So let's get started. BarsDev is the leading nearshore technology solutions company. What we do is basically architect and engineer scalable and high-performance software solutions. Today, we are considered as one of the fast-growing outsourcing companies with more than 4,000 professionals distributing in almost 600 cities and more than 40 countries. Around 18 months ago, we started a data engineering team from scratch as part of the research and development area. At that time, we were dealing with the technical challenges of growing the business year by year. So after some interviews with the areas to understand the challenges and the problems to be solved, we found at that time several data pipelines being built with different technologies in different teams. To solve this, we need to sustain this growth and enable analytics at scale. The second, analytical workloads with performance and concurrency issues is struggling to support the company growth. Then let's bring to the company the best technology to solve each workload. And the third, people complaining about the quality of data provided by other teams, duplicating pipelines, generating inconsistencies. Here, we need to have data quality and governance in place. So, data mesh to the rescue. That's the full architecture following the same organization we had in Zhamak's book. Don't try to read everything. We're going to zoom in each part of this diagram. To explain the decisions we made during this journey, I'm going to explain the problems and solutions, organizing them in 4 pillars from the data mesh. First things first, having this domain ownership embedded in the culture, we understand the boundaries to define domains, find the owners, and keep the autonomy and ownership. But this time, applying that also to analytical data. As you can see in each domain using components they need from the data platform to reach their goals. In this case, we have our core domain talent as a data producer. They need at that time to use the Vision to send data from relational databases to Kafka cluster, our event bus. After that, the data is stored in S3 buckets in the domain's AWS account. To transform this data in batch or even streaming, they can run the compute in their own Databricks workspace. The same for orchestration and data models on dbt repositories. After generating the key assets, it needs to be shared. And for that, we also have some options depending on the data consumers. For example, APIs, Kafka, roles, and attributed-based access. And recently, we start to migrate to Delta sharing. And here is where the data as a product pillar comes in. The situation we found is kind of a default situation for most of the companies. This product thinking requires sharing capabilities to sell data to other domains, making the data producer in charge of the catalog, observability, quality, security, and performance, which happens only because they are the owner and need to meet the data consumers' requirements. The consumers can be other applications, other Databricks workspaces, BI tools, and so on. As we can see in the arrows showing the data products being shared. The third pillar is the governance. That seems to be the hardest to implement because of the decentralization. So that's why we need a lot of automations to make sure the domains will follow global policies defined by the company or even local policies defined in the domain. So we found that great gatekeepers in the domains, also good practices in data privacy and access, some non-formal agreements. However, there is no global policies and workflows, no centralized metadata management, lack of automation standards. So we need to improve that with automation. As we can see, for all those three pillars, we need to offer some capabilities to enable data mesh across the company. The data platform is not only to solve technical problems, but also to reduce the complexity of organizational and cultural changes needed to apply data mesh. In our case, we had to give a solution for each problem, and we heard things from other teams like, I can't prioritize this data mesh right now, or I don't have enough people with skills to make it happen. The data platform is much more than we need for now, or even the learning curve will delay the projects. For each case, we try to find a solution, and the self-serve data platform helped a lot in that. Not only that, but regarding people and roles, we also lending people to the domains, not trying to solve the problems centrally in a centralized way again, but we try to fix the roles and the responsibilities for each one. So we identify and solve their current problems using features that we can reuse for other domains. We started doing it for them, help to hire the people layer. We dedicated a data engineer as a customer success in the domains projects in order to make sure the capabilities will be used in the right way, or even to understand the business cases that we need to solve with platform. And also we developed capabilities to accelerate the adoption. To understand more about this self-serve data platform, let's see how we're managing this as a product. With so many capabilities to deliver at the same time, to start onboarding domains, we realized it would take too much time for starting to deliver value to the business. In other words, time to market is important for the domain adoption. So we choose managed data tools like Databricks, Monte Carlo, Fivetran, Astronomer, Atlan. The idea is to avoid wasting time, keeping the services running, cluster maintenance, and provisioning, and so on. And that way we could prioritize the development of things that really cut the time to develop data pipelines in each domain. Understanding the domain's needs and define the scope, we developed some components that to accelerate the adoption. Here we can mention Kafka Connector Manager to automate replication setup, helping the domains to easily send data from operational to analytical world. Databricks CD to promote Databricks jobs to production, checking for some development best practices. Domain Setup Manager using Terraform to provision components for the domains in a standardized way. Data platform tools to set standards for generate data lake layers, partition keys, update lineage, and so on. And Airflow tools, a DAG generation based on YAML files and Airflow operators. To finish, I want to show you how Databricks and Monte Carlo help us to deliver solutions for the problems that I mentioned at the beginning. The solution one, we use it Spark to optimize the processing for terabytes of data in parallel. So today we can scale horizontally and keep growing with this data product. The solution two, the Lakehouse, gave us since the beginning of the data platform the opportunity to onboard all the data users. At the same time, we reached some important milestone in terms of data mesh implementation, providing one Databricks workspace for each domain, sharing and governance capabilities also, in which Jason will cover some. For the solution three, regarding the data reliability, Monte Carlo adds some important capabilities to the BarsDev data platform, where data producers and consumers can create custom monitors, use anomaly detection algorithms, and instant management to deliver their data products. The people in charge of data operations in each domain access Monte Carlo, see only the data sets available for their domain, manage incidents, evaluate some findings from ML models, be notified in PagerDuty or Slack channel from the domain. So due to the time, I compressed the presentation, so send me a LinkedIn or email message. I will happily fill in the blanks. I hope you understood everything that I said, and if you have any question, don't hesitate to ask in the Q&A at the end. Now I'd like to pass you over to Jason, who will talk more about Databricks.
Excellent. Thank you so much. So I'm going to talk a little bit about, who Databricks is, and then, how you can implement a data mesh on Databricks. So first of all, what is Databricks? It is a lakehouse platform. So we've developed this thing called the lakehouse, and it's meant to have the performance of a data warehouse with the economics of a data lake. And so if you think about it, you can have one platform that you use for all of your use cases. So at the bottom, you've got all your data stored in cloud storage, which is the cheapest, most reliable place to put your data. And then Delta Lake is a layer on top of that provides asset level transactions and consistency on top of it. And it's the most popular open source lakehouse format there is. On top of that, we have Unity Catalog, which is the governance layer for the lakehouse. And then on top of that, you've got all your different use cases that you can do. So anything from data warehousing and data engineering to streaming and data science and machine learning. And the idea behind this is we want the lakehouse to be simple, multi-cloud, and open. So it's simple in the sense that you only need one platform to do all these things rather than 4 different platforms. It's multi-cloud, so this is built from the beginning to be on all the major public cloud providers. And then it's open. So because it's built using open standards and open source with things like Apache Spark and Delta Lake and MLflow, you can basically write your applications in one platform and then have portability to take them to other platforms that support those same open standards, even on-prem if you need to. So without further ado, a lot of times I get the question like, should I have a lakehouse or a data mesh? And they're not really competing things. It's like, I kind of see data mesh as it's almost like, agile, versus waterfall. Like you can't compare like agile methodology to, a technology. So the lakehouse is the technology. It's the technology platform that allows you to basically do both all of your data engineering and all of your artificial intelligence on a single platform. And data mesh is an organizational paradigm that allows you to structure your organization and use complementary technology like a lakehouse to be able to do it. And the main reasons that I've seen customers adopt data mesh is because they want more autonomy. Essentially, you want to create these domains that are very close to the data, and they have the subject matter experts in those domains. Because they know the data best, they can basically create the data products that other organizations or other domains use. And because they're closest to the data, and they have all this expertise, they can actually improve the data quality much better than somebody else who is in a centralized data team. And finally, you want to be able to have more collaboration and productivity. Ultimately, people are implementing data meshes because they want to innovate faster. They want to be able to get these data products out. They want to have autonomy so that these teams can decide what's the most important thing to build for their team. And they want to get to what's called fair data principles, which stands for findability, accessibility, interoperability, and reusability. There's 5 core processes you need to think about with a data mesh architecture. At the bottom, you've got platform operations. So I think Zhamak talks about having the ability to self-serve your infrastructure. So if you're a domain and you're trying to generate these data products, you want to be able to point and click and get the infrastructure that you need to be able to do your job, rather than having to put a request into some central team and wait for those resources to come to you. Or, in the old days, you'd have to, make a requisition for some on-prem hardware to get delivered to your data center. And with Databricks, we have the ability to easily spin up clusters and then attach notebooks and start working. We also have Partner Connect built into the platform. So you can find partners like Monte Carlo to be able to plug it into your existing workflows and basically use the tools that make your team the most productive. In the middle, you've got federated computational governance. So Databricks has this thing called Unity Catalog, and it's a centralized governance layer that allows you to unify the governance across what you would do for data lakes and for data warehouses. It also unifies the ability to do data discovery on all of your assets, as well as the access control against those assets. So you can do fine-grained access. And once you grant access between a user or a group to those assets, it follows them along wherever they log into in Databricks. And then the top, you've got these 3 different domain-specific things that people do with data. They're producing it, they're publishing it, and they're consuming it. So as a member of a domain, I want to be able to consume data that other domains have created, and I want to be able to also produce new data assets using ETL, and then be able to publish those and choose who I'm publishing them to. And that publishing could be to other domains within my enterprise, or it could be to external groups as well. So I talked a little bit about Unity Catalog already, but it's basically data as a global product. And then we also have this thing called Delta Sharing, which is an open protocol. It's the first open protocol for data sharing, and allows you to basically share data that's already in your Delta Lake with other recipients, either within your existing company or even outside your company. So you might have the need to share data with partners, suppliers, customers, and this allows you to do that. So these people don't have to be inside your identity provider to be able to do it. And people also are using it within companies because they want to traverse, the boundaries around cloud regions, or even, from one public cloud to another public cloud. With Delta Sharing, you have the ability to do that. And because it's open, the recipient doesn't even have to be on Databricks. They can use any sort of open source client, that's already baked into Apache Spark or Pandas. Or we've got partners such as Power BI and Tableau that have already baked in this Delta Sharing client into their BI tool. In terms when it comes to scaling the data mesh, in this example, I've got, each of these different hexagons as a domain. And then the domain, if you're crossing a cloud region boundary, or if you're crossing a cloud boundary. So if you're working with GCP and AWS, or AWS and Azure, you can basically use Delta Sharing to easily share this data between the different domains. And if it's from Databricks to Databricks, it's just a matter of sending a link after you've authorized it. If it's outside of Databricks, it's basically just sending that link to an authorized recipient. And then once they're authenticated, only they will be able to share that data. Finally, like whenever you go to organize a data mesh across your organization using Databricks, there's a couple different ways to do it. These are the two most common ways. One is harmonized and the other is hub and spoke. The harmonized one, you can think about, this is like the truest form of a data mesh. So each one of these domains in the green hexagons, they're basically, they're generating data assets, they're producing those, and then they're publishing them, and they're deciding who's allowed to see all these different data assets. And so you're using the data catalog or the global catalog in the middle, mostly to do discovery. So people have a way to search and discover these assets. On the other side, you've got a hub and spoke. And so with this one, you've got that catalog in the middle, the global hub, but you're kind of centralizing the publishing these assets. So everybody in the data domains can still generate them and consume them, but you're putting some structure around or governance around who's allowed to share them to who. So these are two different models that we see. I don't think either one of them is like more right or more wrong than the other. It kind of just depends on your organization and how things are set up.
Thanks, Jason. So for our last topic today, I'll share a little bit more about a little bit more detail from Matthias in the Bairesdev case study and how Monte Carlo can and data observability can support a data mesh network. So first, Monte Carlo sits across the modern data stack. So using Bairesdev and their integration as an example, Monte Carlo integrated with their Databricks Delta Lake, including their S3 log storage and logs, Hive Metastore, and Spark. From an orchestration standpoint, as you saw from Matthias's presentation, we're also integrated with Airflow and dbt. And then finally, Tableau as their business intelligence layer for end-to-end data observability. And what I mean by observability is the ability to detect a data anomaly or incident anywhere along this pipeline. So for instance, as soon as Monte Carlo detects that a table was not updated when it should have been, or if the data itself is erroneous or partial or not accurate, it automatically notifies the data team owners or domain owners via collaboration tools. So in Bairesdev case, you can see there for both Slack and PagerDuty. But we don't want to just sound the alarm when a data incident or anomaly occurs, but actually equip data engineering teams to actually resolve the incident. I'll share a little bit more about how we do this in a little bit. And then finally, Monte Carlo also equips data teams to prevent bad data altogether by helping them understand downstream impact before making a field or table or schema change, as well as equipping them with data health insights to proactively ensure data quality. So as you've already heard from Matthias and Jason today, Monte Carlo is built to support the data mesh network, including support for the 4 core principles that we talked about earlier. I won't have time to go into a lot of detail for each of these, but figure what's most helpful is to always see it in action. So let me switch over real quick and actually show you what this looks like in the product. All right. So what you're seeing now is one of the first screens you'll see when you log into Monte Carlo. Just to orient you a bit and just to recap what we just mentioned, one of the first things that we want to equip teams with is out-of-the-box monitoring. And one of the first places we want to look is on pipeline health. So across all of your production tables in your Delta Lake, what we want to do is automatically deploy freshness, volume, and schema monitors. So this goes into kind of the self-serve element of data infrastructure in terms of how we can make monitoring and observability accessible for all domains and domain owners. So in this first instance, freshness, were all my tables up to date when they should have been updated? Volume, were the size of the updates what I expected? And were there any significant schema changes that would impact data quality? So again, that applies to all production tables out of the box without any configuration or thresholding. We use ML to form a baseline of what the expected behaviors are for both when a table was updated, the size of updates, et cetera. And then with those, form thresholds to inform what's an anomaly and what's not. But we also know that that's pipeline health. We also want to help you with data quality as well. So a couple examples here are monitors that you can opt in at the field level. Or if there's a specific table where you want to check all fields. So by Flowing through a Spark cluster, we can issue things like a field health monitor, which automatically out of the box gives you about 20 or a little over 20 metrics, such as percent null, percent unique. Also gives you mean percentiles, basically looks into the data itself, learns behavior again using ML, and will let you know if a certain field deviates. So for example, if you have a transaction table where a price should always be between $80 and $120, as soon as it deviates from that, we can inform the team so you can take action on that field. And these monitors are easy to create. So again, going into self-serve infrastructure, to create a monitor is as simple as a few clicks. You can also do this as monitors as code, but you have to add just a few fields here, and it's quite straightforward. You select the table. You can let us know if this is something we should track all fields or if it's specific fields. Again, this is something that you can do through here or as monitors as code. Define the schedule, and then just name it, and then that's it. That monitor is deployed. Again, for a field health standpoint, 20 metrics out of the box, and we'll let you know as soon as this field deviates from what we've learned as the norm. So then that's the detection aspect. The second thing we want to do is self-serve how we can actually resolve an incident. So by domain, you can go in and understand as soon as an incident occurs, how do we resolve this? So let's just take a look at this for an example. One of our latest incidents. When you log in to resolve an incident, one of the first things you want to understand is what's the breadth of the impact. So in this case, we can see there are 7 tables that had a similar anomaly. What we want to do is essentially group like events into a single incident. So your team's not always getting alerted for every single table or every single incident, but ones that are related that we think have a similar root cause. You can quickly assign an owner and a severity level that will flow through to tools like Slack and PagerDuty, but also see downstream impact. So in this case, we know that one Looker dashboard looks like was impacted because of this incident. And because we have an integration with Unity Catalog, we can also expand to understand what was the downstream impact of this. So in this case, we can see that a Looker dashboard was using this with Delta table. So to go back to the incident itself, one of the next steps we want to do once we understand, okay, this is actually an important dashboard, this is something we want to resolve, is starting to understand the incident. So what happened here is we basically expected an update to occur to this table, but there was no change in the table size during this period of time. And you can see the same occurred here in the lineage edges PG table, same with lineage vertices FE, lineage vertices PG, no updates. So similar patterns. So now we want to start conducting root cause and understanding what happened. It looks like there might be actually a DBT model run that resulted in an error. And that's likely where we want to start conducting our root cause. So again, this goes into self-serve data infrastructure. One other thing that I want to show is more from a data product standpoint. For every Delta table within your lake, you'll be able to go to a similar catalog page like this. And this is where you can start really understanding the nature of this table from a data quality and data reliability standpoint. Again, we deploy these monitors out of the box for freshness and volume. You can see that using ML, we know when the next time the table should be updated, as well as the expected size of the next update. From a data product standpoint, what we want to do is equip teams to actually be able to document the information that they need. So whether it's adding documentation to this table, whether it's adding an assigned owner, whether it's giving a specific tag, let's say, for instance, we know that this table is one of the products that the data science teams uses. So we want to assign that as a tag. You can very easily do that from here. One of the couple last things that I want to show you is how we can support domain creation. So creating domains within Monte Carlo is quite simple. You can see a few examples of it here, but within a few clicks, you can create the domain. So for instance, if we wanted to create one for machine learning, we can use that same tag as before for data science. And then as easy as that, we've created a new domain. And within domains, create authorization groups so you can have clear domain ownership as well as accessibility. One of the last things I want to show you is one of the recent releases that we had, our data reliability dashboard. Ultimately, our goal is to help you drive reliability across the organization. Again, enabling self-serve, but also federated governance. How do we standardize how we measure reliability? So one of the first things that we want to show you is how many incidents have occurred recently and how many incidents per table, again, by domain. But we also want to show you how are the tables performing. In our case, we're doing great from a freshness standpoint, a volume standpoint, custom business rules that we've deployed as SQL rules, as well as field health. So again, that's data quality itself, 100% across the board. But what we also see is our time to response actually spiked in August. So that's something that we want to start exploring. It took us 4 hours to resolve an incident in that around that time period. So this is areas where we can start improving. You can see it again by domains. We're filtered down here to our Databricks domain internally. But this is where you can start really getting a full view of your data reliability through Monte Carlo. So with this said, and again, I couldn't cover everything today, but hopefully gave you a quick preview of what Monte Carlo can do in terms of supporting both data observability, data reliability, but also how we support data mesh. So with that said, I'll welcome Matthias and Jason back to the stage, and we'll take any questions you all have at this time.